Hi everyone, nice to see all of you. So I'm gonna yeah. So can everyone see my screen? Can you see it?
Yeah.
Yeah, right. Okay. Okay. So let me first introduce myself. My name is Abhash, and I have a MSc in Computer Science from the University of Southampton, and I'm a researcher at CAIR-Nepal, and I'm also a co-founder of Pandey. It's a startup company, and we provide any and all kind of digital services. So this is the agenda for today. So firstly, we're gonna talk about what are biases and should we even care about like biases. So I think we've all used ChatGPT, Gemini, and all that, right? And they are quite powerful and they're quite useful. But then, are they fair? That's the main question. So let's say like you might have a recruiting system, but then it might filter out your CV just because you're from a certain country or you're from a certain race, right? So that's very unfair. So I think it's a very big problem that we need to solve, and it's going to increase even more in the upcoming days. Um, yeah. So I'm going to introduce some kind of biases to you, and yeah. So AI is used everywhere these days, like hiring system, criminal justice, content recommendation, healthcare, you name it, right? So what happens when you have biases in these kind of systems? So in the hiring systems, you might have CVs getting filtered out because they are like a certain gender or like from a certain place, or they might have a certain surname, and it might get filtered out, which is quite unfair. And in the criminal justice system, as Dr. Chetri said, people of black color were getting unfairly penalized for minimal crimes, right? So similarly, like loan approval systems, you might have your loans getting disapproved because you're from a certain country or a certain demographic, right? Those kind of things. So what's the societal consequences of that? You might have more hateful content promotion online, right? You might have perpetuation of stereotypes, unfair policing, and people are also going to lose their trust in the kind of technology that are being implemented, right? So overall, it's going to create like a social disharmony, and it's going to affect the society negatively. So yeah. And then I'm going to talk to you about two kinds of AI, sub-symbolic AI and symbolic AI. The most common type of AI that you know about is sub-symbolic AI, which is all the neural networks, computer vision, large language models that you use right now. But not many people like know about symbolic AI, which is like the origins of AI. So it's also called good old-fashioned AI. So you have things like first order logic, decision trees, if then rules, and all those kind of things in the symbolic AI. So you've got things like knowledge graph and all those kind of things in symbolic AI, right? One of the most famous examples is IBM's chess playing system that had like symbolic search trees and decision-based functions. Um, yeah, so that's like symbolic AI. And then when you go into sub-symbolic AI, it's like image recognition, speech recognition, NLP, and all that. Symbolic AI is very good at taking unstructured data, taking random data, and taking a large amount of data and learning a pattern from it. But then symbolic AI does not learn from pattern. We have to encode the pattern in it, right? So sub-symbolic AI is, yeah, those kind of things. And then, yeah, what are the weaknesses of sub-symbolic AI? So you've got like a sub-symbolic AI, then you feed some data into it, and it's going to give you some kind of output. But we don't know what happens inside it. So it's like a black box, right? Sub-symbolic AI. That's one of its main weakness, and that's why it's not explainable and it's not very accountable in some sense. And that's why it's very susceptible to biases. So, for example, let's say I've got like a sub-symbolic AI, right? But then I feed it a lot of data which is very biased, right? The sub-symbolic AI itself is going to be very biased because of the data it's been trained on. So that's the weakness, right? And then, yeah. Okay, so these are some common type of biases that you see, but then there's no common agreement among researchers about the taxonomy of biases. So right now you've got things like algorithmic bias, sampling bias, representation bias, generative bias, measurement biases, and all that, interaction bias, and all those kind of things, right? So all these things are biases, but then they have their own kind of reasons how they arise and how they affect you, right? So for example, like a measurement bias, it's going to arise from faulty measurement while collecting the data, right? And like generative bias is like, let's say you tell some kind of image generation AI to generate some kind of image, right? And it's going to generate some kind of biased image. So let's say you tell it to generate, okay, generate an image of a scientist, right? So it might generate someone that looks like an Indian or a Chinese, but that's a bias, right? And then what are the common kind of approaches that are being used right now to mitigate these kind of biases? So we all know that like whenever you're trying to train a machine learning system, there's like three main steps. First, you gotta clean the data, then you feed the data to the algorithm, then it's gonna give out the output, right? So biases can arise in all of these three steps, right? So in the pre-processing step, you've got to clean the data as much as possible so that all the demographic are represented equally and all those kind of things. And in the algorithmic part, which is the in-processing bias, you need to do things like demographic parity, equalized odds, and all that. And then after the result comes out, you've got to again check if it's biased or not. So you can use tools like Lime and all that to figure out if the outcome is biased or not. Yeah, so this is like just like a visual representation of that. And then what we're planning to do is combining this symbolic and sub-symbolic AI and try to mitigate those biases. So for example, you might have biased data and a biased output in the sub-symbolic part, but then if you encode a rule in the symbolic part and say that, okay, even if the person is from X country, do not filter out their CV. Or even if they're like from a certain demographic, uh, they should receive a loan, right? So that's sub-symbolic AI part and yeah. So you use that symbolic AI in order to mitigate the bias that arises in the symbolic AI. And that's also like one of the researches that I'm doing right now at CAIR-Nepal. So yeah, yeah, that's like a hybrid approach, but then it also has some limitations. The system is very complex, right? And then you need to continuously monitor and manage the rules that you put in the symbolic AI part. And then also, whenever you're trying to increase the fairness of a system, you definitely reduce the accuracy, pure accuracy of the system, right? So there's that problem as well. So you've got to find like a sweet spot of the accuracy and the fairness. And that's what we're trying to do at CAIR-Nepal in one of our researches. And yeah, that's my time. Thank you.
Yeah, thank you, Abbas. I see some interesting question. Maybe Neeraj, Manjula, you can take note of that, and then we can have a discussion afterwards. And During the interactive session, I'll enable mic for all the presenters so that you can directly ask questions, not just type. So keep posting. And yes, someone was asking if the slides will be made available. I've shared the link. So all the slides will be available in that GitHub repo. The next, our presenter is Ashish, who is also working on some responsible AI research. He will give you a brief overview of what he is working on. And then we'll have a heritage graph presentation. After that, we'll look into the essentials of research writing and research ethics and best practices. And today we'll have a small interactive session as well. So Ashish,
Is the slide visible?
yeah.
Hello?
Yes, it is visible.
Okay. Shall I start?
Yeah.
Good evening, everyone. My name is Ashish Pandey, and I'm currently enrolled as a research intern at CAIR-Nepal. And today I will be presenting on the topic analyzing social and cultural biases in large language models, especially in insights from the Nepalese context. Here is a short info about me. Before we get into the details, let's take a brief look at the structures that syllabus or discussion structure we will be talking about. We'll start with an introduction in LLMs and their impacts, then move into the discussion on how representative these models are, and we will explore what the bias actually means, and specifically we will be focusing about societal and cultural bias. Finally, I will be explaining why studying these biases in context of Nepal is so important. Let's begin with the basics. What exactly are LLMs, or say large language models? Essentially, these are AI systems trained on enormous amounts of text data. They are designed to generate human-like responses, enabling a wide range of applications, such as real-time translation, personalized learning, and even aiding in medical research or any other scientific research. Think about the tools like GPT-4, Llama, Bard, Gemini, and all many more. While these systems are incredibly powerful and innovative, their impacts on our daily lives are much more profound. And that's why it's crucial to understand how they work and potential biases they might carry. Uh, Moving on to our next point, we have a question. Do these language models truly represent the diversity of our global cultures and communities? The reality is often they don't. Many studies have shown that AI models prioritize dominant cultural and the data that is dominated by the cultures that are frequently available in the internet. And in this case, they try to misrepresenting the marginalized groups. For example, the research has indicated that the black defendants are more likely to be flagged as high risks for reoffending compared to the white ones, is already told by SARS. And it's not about the language only. In the current era, advances in AI, like all of you might have known about the Gen AI, that has been made more possible to create the realistic fake images or videos, which can be used to manipulate the public perception or else. These issues raise the important question about fairness and representation in the technology that we are regularly rely on. Here is a study from MIT which found that the language reward models means the models which guide AI responses based on the factual data. But the irony is that this model also can still exhibit the political bias. The research shows that these models tend to be on favor on left-leaning or right-leaning perspective, while they were purely trained on the factual datasets. We can see the bar and interpret it, the biases they offer. Now let's bring this discussion closer to home. Whenever we consider Nepal, we can see the similar pattern of underrepresentation. The Nepalese cultures and languages are not always accurately captured or reflected by these models. This underrepresentation can lead to the problem, such as incorrect translations and biased interpretation, which may have a real-world consequences in how Nepalese users interact with and benefit from the AI systems. Let's revise what the bias was. Bias in context of AI refers to the prejudice or an unfair preference, often arising without sufficient evidence that might be against a particular person, group, or whole idea. Today, our more focus is on societal and cultural bias. This type of bias is deeply embedded in the norms and values of our society and can be amplified when AI systems learn from the historical data, the data which are already available in the internet, and they are not biased free. An example already mentioned by sirs, Amazon's AI recruiting tool, which was found to downgrade the resumes, which contains the word women's or the similar information related to women. Why this happened? Because it saw that the whole data set was, whole the company was male dominated. Essentially, the bias present in our data can be encoded into the models, right? So leading to the unequal and sometimes harmful outcomes. And in essence, the root cause of these biases lies in the existing datasets. So when these models learn from such data, they can end up having those kinds of biases. This understanding is the first step toward developing more responsible AI. Finally, let's talk about why it's so important to study these biases, specifically in Nepal. First, by values and communities, we can better understand the gap in how these models operate. This includes recognizing how underrepresented groups, local languages, and unique customs are often overlooked. By identifying these gaps, we can work towards correcting them, ensuring that AI systems are fair and inclusive. Ultimately, this will not only benefit Nepal, but also contribute to the global conversation about developing responsible and unbiased AI systems. That's my time. Thank you very much.
Yeah, thank you, Ashish, and also Abhash. So this is what Ashish is working on, understanding how biased LLMs are, how representative LLMs are in the context of marginalized and underrepresented communities. And we are looking from the Nepalese context. Abhash is looking from the global perspective of about the bias and fairness, what kinds of bias and fairness. He's looking into both data and algorithmic aspect. And this was the brief overview about their works that they are working on. And we have one last presentation from Niraj and Nabin. That's about the heritage graph. They will be mostly talking about knowledge graph and why are they using knowledge graph. And then we'll move on to the essentials of research writing. I just want to answer the question that someone posted on the channel, like the message saying, "Are humans fair?" No, humans are not fair. Bias is inherent in human nature. It's needed to make the decision. It's important aspect, But having said that, what kind of bias we want? For example, if you, as a human, you may be biased towards certain people, but you may be biased because of their accent, not just because they are from the certain group of the certain race. But what is happening with the AI system? It's not saying, okay, this person has something bad, so I'll treat him badly, or I don't like him. AI system is saying, okay, this person falls into this category, so I'll treat them unfairly. Like the one Ashish was saying, downgrading women just because he was a woman in the job interview, which is not what we want. And that's what we are studying when we say we are studying bias and fairness in AI. I'll not take more time. I'll let Niraj and Navin so that we could have more time towards research writing.
Okay, I'll start sharing my screen. So, hello everyone. Warm greetings to you all. Myself, Niraj Karki. I'm a second year computer engineering student at Pulchok Engineering Campus. I'm currently working as a research intern at CAIR-Nepal, as well as I'm also the executive member of R&D IEEE Pulchok. So, one of the project I'm working at CAIR-Nepal is HeritageGraph. So, I would like to start with a quote. To chart meaningful path forward, we must understand where we have come from. So it's important to be designated with our culture, history, roots. Uh, while talking about Nepal, it's culturally rich country, having 4 UNESCO World Heritage Sites. They promote Nepal's tourism across the world as well as boost the economy of Nepal. Tourism is a major part of economy, contributing about $82 billion NPR in the fiscal year 2023-2024. So tourism plays a key role. But uh, in today's context, currently, if we see, mm, the state of these heritage sites is declining. 2015 earthquake was one of the major reasons for it, which was devastating as well as caused the massive damage uh, to the heritage sites. If we see, Changunarayan Temple is currently at the verge of extinction, as well as an article published in the Rising Nepal, Kushunda culture is slowly disappearing. The major reason for this is lack of the manuscript history and their declining language. So to eliminate cultural legacies here at CAIR-Nepal, we are working at HeritageGraph. So the motivation behind this project is the declining state of our cultural heritage, preserve and promote our cultural heritage, digitalize our culture, and make it available for the global community. Therefore, HeritageGraph is a step taken by CAIR-Nepal to preserve and promote our culture. It is important to digitize, organize, and make heritage accessible for future generation. And the objective behind this project is using knowledge graph for Nepalese cultural heritage, integrating AI to generate insights from cultural data set, make heritage accessible for the researcher as well as global community. So why we have chosen heritage graph? Uh, in order to preserve and digitize our culture, support research and innovation, as well as foster global collaboration and leadership. So for this project, we have used the technology knowledge graph. Knowledge graph is a structured representation of knowledge using nodes and their relationship. For example, Dasai is celebrated by Nepalese. So here we see Dasai and Nepalese are two nodes, and is celebrated by a relationship between them. And another example, we are attending this workshop. We and workshop are two node, and are attending is a relationship between them. So it is a way of representing this the semantic relationship. So why we have chosen knowledge graph? Our objective behind this is it provides human comprehensible as well as machine readable data format. It is an effective method of visualizing the data. It captures the relationship between entities, and it can be integrated with AI and can be used for semantic research. And further, I would like to call my colleague Nabin for presenting about it. Thank you.
I guess my screen is visible.
Okay, it was visible, not now. So in the meantime, Navin shares the screen.
Okay, so this is the overall architecture of the heritage graph, and we are trying to make this at CAIR-Nepal. And I will dive into the each component of this heritage graph one by one. So the first is user input. So basically, there are some contributors on the heritage graph platform. Though they will be providing their contributions like all the data that is related to the cultural heritages, for example, like text, images, audio, video recordings, and maybe like oral traditions or academic research. So right now we are trying to take those contributions through the form that is at the heritage graph platform, and we want to support the multiple formats like text, CSV, JSON, and images. So and also we are also trying to accommodate the all the multilingual contributions as well. And the inputs that is taken from the input component, it goes into the knowledge graph generator. And the main purpose of the knowledge graph generator is to basically convert the raw input into the structured triples. And triples are basically a data structure, and they have the structure of like subject, predicate, and object. And here the subject and object is entity, and the predicate is the relationship between them. And in knowledge graph generator, there is this entity extraction where we use the NLP techniques for identifying the key entities. For example, the contributors provide the corpus of the text, and the entity extractor will extract the entities like Pashupatinath temple, Dasai festivals. So it will be used for making the subject and object part of the knowledge graph. And then we have the relationship mapping. So for example, if there is a knowledge graph that says like Dasai is celebrated in Nepal, is celebrated in is the relationship that is again will be found with the help of the NLP techniques. And we have this ontology alignment. This slide contains some jargons related to the symbolic AI, and the ontology is related, one of the terms related to it. So ontology can be understood as a schema for the relational database, and ontology helps us to validate the data in the knowledge graph, but it's the more than the schema. So basically, if I have to summarize the ontology in one sentence, it's the explicit description of the concepts in a domain. In our case, the domain is the cultural heritages, and it uses the predefined cultural heritage ontology. So we are developing the ontology at CAIR-Nepal, and we are reusing the CIDOC CRM, which is the ISO standard for cultural heritages, and we are reusing it. And yeah, so the knowledge graph that is generated from generator, it goes into the validator, so it confirms the alignment with the project ontology. So the ontology that we are building, for example, if the ontology has the festival occurs at location. So for example, like contributor contributed data that Dasai occurs at Pashupatinath, but the Pashupatinath is not a location, it's a temple. So that will flag as a contradiction, and that will be handled in the later stage. So this helps to makes us like explicitly well-explained knowledge graph, and it also helps us to flag the contradictions. Like, for example, if there are any kinds of data related to the Lumbini, so if someone contributed that, like something is happened in Lumbini, so if the data is related to, like, says Lumbini is in India, but it's the contradictions according to the ontology. So this will be flagged, and that will help us to make us the really good cases. So cases are basically knowledge graph for short. And then it goes into the quality assurance. So at the end of the day, we don't want to rely on the piece of code or AI. So we have the human in the loop. So here the humans are the domain experts, since we are working in the cultural heritage domain. So we will be having the historians and anthropologists, maybe also the archaeologists, for reviewing the knowledge graphs and flagging the ambiguous entries. For example, like, we don't want, there might be like disputes and other things in the cultural heritages, and for sure, so in that case the domain experts will decide like what can be considered as a really true, and they will provide the feedback loop, and this will again go in the curation. If the knowledge graph is flagged, then it again goes in the curation. And yeah, and there is this translator. So we also want to have the knowledge graph to accessible across the diverse audiences. So it's really crucial for like giving the support for the multi languages. So for example, it also helps us to preserve the semantic context. So for example, like guti is a word that can be said committee in English, but it does not carry the same meaning. So the having the cases in the multi-language helps us to preserve the cultural nuances as well. And this is the middleware, which is just a security layer between the components of the heritage graph. And yeah, this
Okay,
will okay.
just sorry, I'm just saying quality assurance. I don't know if you're moving your slides.
Let me.
Okay, yeah, now I see middle.
Is it visible right now?
Yeah, yeah.
So yeah, middleware is another security layer that authenticates user contributions and restricts the access to the sensitive data, as well as the helps us to protect the data from the external databases, and also helps us to connect to external databases and vice versa. And finally, when the knowledge graph is finalized, it gets stored in the triple storage, and the storage will support the Sparkle queries. So Sparkle query can be understood as a SQL queries to the relational databases. So it helps to query the graph database, and it provides the interoperability. So one of the advantages of having the knowledge graph is like it is considered the franca, meaning it's the standard format. So if once we have the data in the knowledge graph, so it can be used for any kind of problems, whether it could be like semantic web, explainable AI, or AI in general, or also as a database, another database. And most of the countries and most of the like European countries are using the knowledge graph, so we can also able to connect with them for the better accessibility for the audience. So yeah, again, this is the architecture, and this is a very high level overview of the progress that we have achieved right now. So this is the heritage. We have built the heritage graph platform, and we are also like developing the ontologies for the heritage graph, and we are using the auxiograph for the knowledge graph database. So this is the team, and you can find more information about our project on the CAIR-Nepal's website as well. And thank you.
Yeah, thanks, Naveen and Niraj. So, before I think starting research essentials of research writing, I want to give a brief overview of what knowledge graph is and why we are using knowledge graph. The big picture, basically. So, what you can think of knowledge graph, it's a graph-based data model, and the advantage of graph is like it helps to provide research context. Now, you may be saying, why am I not using graph and what's special about knowledge graph? Uh, Before that, let me give you an example of advantage of graph. For example, if you were to construct a graph about your friendship, you can connect your friends has something, and then if you want to predict what will be likely the other friend. You can predict the behavior of the other friend that you may have, right? Because having a connection, you get the richer context, more information. That is not possible with the tabular data. I mean, the richer context that you can build with the graph. That's why we are using knowledge graph. Now, why knowledge graph? Not just graph, because we just don't want to say, okay, A is connected to B, something like that. We want to have the richer semantics. When I say A, what does A mean? We just don't want to treat something as just piece of a string, but as a real world thing. That's where the ontology comes into play. It models the real world and has the interpretation of what that means. For example, in ontology, you define classes and properties. In the class, if you say person, then you have the real definition of the person saying it's a human being. So anywhere it's being connected, you know now it's not just a random string, it's representing the human like us. What are the advantages? It helps to improve AI and knowledge graph. It helps to improve search. One of the prominent example that you can see is the Google search. When you do the Google search on the right side, you see a small box, right? About author, something, something. That's coming from the knowledge graph. Basically, Google is using knowledge graph to improve their search system. Nowadays, people are using it to improve large language models to provide richer context information to avoid issues like hallucination. It's used in medical bioinformatics, all kinds of medical domain to provide a strict reasoning, all those answers necessary, for example, about disease, genomes, and how they relate to each other, and the implications as well, because there the error you want to have is almost close to none. That's the big picture about knowledge graph. We'll be discussing about it later. Now, what I want to ask is maybe we want to have a 5-minute break before starting and the essentials of research writing. It's a long one. So let's start. Yeah, have a coffee, grab a coffee, and be back here 5 minutes. You don't have to drop. You can also take this opportunity to discuss if you don't want to have coffee. I know it's a little bit late in Nepal, and be, I'll just.
Sir, there is a question in the
Mhm.
chat.
Okay.
So, by Krish Roniar, he says, can we decouple an AI's core reasoning from its data or learned biases, enabling it to critique its own output or inherited biases, like
Okay. Yeah.
humanist like prejudices from rational judgment? That's the question.
Uh, okay. Yes and no. We can decouple reasoning aspect, but then reasoning also comes from data because data provides the learning experience. To some extent, yes. But if you look from the statistical, the sub-symbolic AI, the current paradigm, I would say no, because it's mostly based on data. But if you look into the symbolic AI, which is based on like the Abhash and other work presenting, that's based on knowledge graphs. Here, it's not based on data, it's based on rules. So you encode all those rules and you reason over data. Those were the old days reason like AI. That okay, yeah, old days like AI system, because if you say AI nowadays, people just understand machine learning and deep learning, which is wrong. So the answer is yes and no. And the future development I see is neurosymbolic, which Abbas was presenting, combining both aspects. Yeah, I hope that answers your question. We'll have all. It's great to have these kinds of questions. Keep posting. We'll be discussing more. And I'll just open the slides so that I can get ready.